I'm going to walk you through a really new project that it's the first time that we talk about it. So I hope you like it, and please ask questions. So in our lab, we deal with the gut microbiome, but not only the gut, also other places where we can find bacteria in the skin, and in other places in the body. And today I'm going to talk about the gut bacteria and how it can modulate weight gain after smoking cessation. So, as you probably know, we are not alone. There are probably about 39 trillion bacteria cells in our body and 30 trillion mammalian cells in our body. This was found by Ronnie Milo here at the Weizmann. And when we talk about the gut microbiome, the host itself can modulate the microbiome by the diet intake, by the immunity, by antibiotics. We also showed before that the circadian rhythm can modulate and alters significantly the gut microbiome, and also the genetics. But the most prominent effect is driven by the diet. And the bacteria, on the other hand, can influence the host as well by secreting metabolites produced by the bacteria that can affect different organs in the body. But when the intersection between, or the connection between the gut microbiome and the host is disrupted, it involves in many diseases, in different places in the body and also in the whole body, such as type 2 diabetes, autoimmune disease, malnutrition, atherosclerosis, and many, many more that I don't have time to show you here. So let's jump into the talk. The main focus of our talk is weight gain after smoking cessation and the role of the microbiome. So, as you probably know, ex-smoker gain weight after smoking cessation, on average 4 kilograms per year. By the way, it's more pronounced or more significant in women comparing to men somehow. And on average, it's 1 unit of BMI over a 5-year period. And this leads to our main focus here. And what we try to see here is how we can manipulate this weight gain and how we can drive more compliance of humans to smoking cessation, because smoking has a major health risk, and the weight gain after smoking cessation has much less risk for cardiovascular disease and other metabolic disease. So the model that we use is a mice model where we expose the mice to a smoking chamber here at the animal facility at Weizmann. Part of the mice were given antibiotics before the smoking exposure. The smoking was for 21 days. The mice were fed with high-fat diet, and then we had a session of cessation. And as you can see here, the red group undergoes smoking exposure and then cessation, and as in humans, the mice gain weight to a similar level as the mice that were not exposed to smoke, and quite similar to the non-smoking with antibiotics. And in here, the antibiotic group that were exposed to smoke and undergo smoking cessation didn't gain as much weight comparing to the ex-smokers group. And next, we tested this phenomena, and I don't have time to show you here, in different mouse strain under different diet, not only high-fat diet, but also no-natural diet. And here with a low nicotine cigarette, and it's the same phenomena. The mice that consume antibiotics had much reduction in weight gain during the cessation comparing to the mice that didn't consume antibiotics. So we next asked, so obviously the microbiome play a significant role in this smoking cessation weight gain. And the question is, can the microbiome control this phenomena? So first thing we did is to look into the microbiome composition, and we can see that the smoking comparing to the non-smoking mice group had a different microbiome composition, and it's completely different comparing to the mice that consume only nicotine by IP injection, and different from the non-smoking mice. Next, what we wanted to show is to prove causality. Usually in the microbiome research, we prove causality using germ-free mice. What we do is the following. We take fecal microbiome from a donor mice, and then we transplant it by gavage to a recipient mice, which is a germ-free mice that doesn't have gut bacteria. And what you can see here is that what we did here is the following. We took fecal donation from mice that were exposed to smoke for 18 days, and we gave it to germ-free mice that never saw any smoking exposure. And what you can clearly see here is that the mice that received, the recipient mice, germ-free mice that never saw any smoke exposure, they had a higher weight gain comparing to the control. And when we did the same, when we took fecal donation from mice that undergo smoking cessation after the smoking period, we can see the same. The germ-free mice that got fecal donation, fecal transplantation from the mice that were ex-smoker gained more weight comparing to mice that received fecal donation from the non-smoking mice. So in here we can show, and we had more work on different diets, different strains of germ-free mice, different donation in different time points that I'm not going to go into here. And the next thing we ask is how? How does the microbiome modulate the smoking cessation weight gain? And one of the approach, among others, that we use in the lab is metabolites profiling using the metabolomics unit here at the Weizmann. And so what we saw, we wanted to look into metabolites that are changing, either going up or down as a result of the smoking exposure, and in addition, metabolites that are affected by the antibiotics. So in here, you can see that the smoking mice had elevated levels of this metabolite dimethylglycine, or DMG, and also mice that received, germ-free mice that received donation from smoking mice at cessation had elevated levels of DMG. And what is DMG? DMG is derived from the diet. It can, so the diet can break down into choline and then betaine, aldehyde, betaine, and then DMG. And what we saw is the following. We think that smoking and the gut microbiome can affect this pathway, leading to accumulation of DMG. And this is the way we show it. So what we did is the following. We gave mice that were exposed to smoke for 21 days, we gave them choline sulfate, tagged choline sulfate, deuterium choline sulfate, and we detected the levels of choline in their feces, and what we can see is elevated levels of choline, which is depleted when we give them antibiotics. Next, we wanted to look into this metabolite in this pathway, the betaine, and you can see that the betaine levels is elevated during the smoking exposure. And next is the DMG. As you saw earlier, we can see that the DMG levels is elevated during smoking, and upon treatment with the antibiotics, there is reduction in the levels of the DMG. And the last metabolites here is acetylglycine. What we found out is that this metabolite, N-acetylglycine, or ACG, is going down during smoking, as you can see here, and treatment with antibiotics bring it up to the levels, close to the levels of the non-smoking mice. So we think that all these choline, betaine, DMG, and ACG are involved in the smoking cessation and are driven by the microbiome, but also by the host. And next, we ask how does these metabolites, if ever, they impact the smoking cessation. So of course, we had the first setting that you saw in the beginning, and now we give each and every metabolite. So let's have a look here. The first one we did is that we use choline-deficient diet to look into the role of choline in this smoking cessation weight gain. So all these mice that you can see here were fed on choline-deficient diet, and you can see that, of course, as you saw before, the mice that were smokers and consume antibiotics didn't gain weight comparing to the control, but you can also see that the mice that were smoking, that were exposed to smoke and undergo smoking cessation, with the choline-deficient diet, they didn't go up to the level of the control. So by using the choline-deficient diet, we could stop the smoking cessation weight gain. The next thing we did is to look into the DMG effect on this weight gain phenomena. So what we did is the following, the same 4 groups, and then in addition to that, with osmotic pumps, we gave the mice dimethylglycine, or DMG. So what you can see here is this yellow group is the mice that consume antibiotics and were exposed to smoke and then undergo smoking cessation. But now, when we give the mice DMG, we can see that the DMG cancel the effect of the antibiotics and bring the weight gain to a similar level as the control. So we think that the DMG is also involved in the smoking cessation weight gain, and we think that it may drive more weight gain in this scenario. And the opposite is about the ACG. What we did is we give ACG diet to the mice, and what we can see here, that the mice that consume diet with ACG didn't gain as much weight comparing to the ex-smoker mice, but we can also see that the mice that consume ACG, even without smoking, had lower levels of weight comparing to the control, which means that the ACG may act even without the smoking setting. And this brings me to the next slide that you can see here. In here, we can see that mice that were not exposed to smoke but were just given ACG had lower levels of obesity and less weight gain comparing to the control. And with the DMG, it's the opposite direction. And with the DMG, we can see that there is less fecal calories and more consumption of calories. And then the human angle, I will go short here. We had a small human cohorts, and we tried to look whether this metabolic pathway is also in the human smokers. This is the microbiome composition. We can see that the human smokers have different microbiome composition comparing to the non-smokers. And we can again see elevation in choline, betaine, and DMG. We will have a bigger N. For this, we may get more significant results. So to sum up what you have seen now, I show you that the microbiome depletion attenuate weight gain following smoking cessation. I showed you that fecal transplantation from mice previously exposed to smoke into germ-free that were never exposed to smoke led to excessive weight gain. I show you that in both mice and human, there is shunting of dietary choline to DMG coupled with decreased ACG that is induced by both the microbiome and the host. And I show you that DMG and ACG may act under a non-smoking condition. We think that the findings suggest that the gut microbiome modulates smoking cessation weight gain that may be used to improve the success of smoking cessation and improve the compliance of people to the smoking cessation, and can even control obesity beyond the smoking setting. And with this, I would like to conclude and thank first and foremost Professor Eran Elinav. Here he is with the normal chow diet, who has been supportive of me and of this project since forever. And to all the people at the Elinav lab, and some of them are here, Shachar and Kim, But first and foremost is Leviel and Uriah who did all the computational analysis, and Leviel who did with us all the experimental settings, and our collaborator at the Weizmann at the metabolomics unit, Sergey and Alex, and also the people at the vet services, Alon, Noah, Yael, and Michael. And to the Division of Cancer Microbiome Research at DKFZ in Heidelberg, Germany, that are colleagues of us. And that's it. Thank you.
Thank you very much, Hagit. We have time for one quick question. Yes.
The smoking mouse, how much smoke did you give to them? Like 1 packet per day in humans, 2 packets per day? What would you translate as a smoking habit?
So it's about 1.5 pack per day. There is a research cigarette that you can give to the mice, and the smoking machine lights the cigarette and then exposes the mice to the smoke. We did it twice a day, and total 1.5 pack. About 1.5 pack of cigarettes. We did it 5 days a week. So it's quite heavy smoking, but one of our reviewers asked if it's not stressful for the mice and so on. So we made a lot of effort, which I didn't go into here, to look into stress-related gene and pathway, and we didn't see it. So by the way, the control mice were in the same room, but they were not exposed to the smoking chamber. So these are the best control that we could think in this setting.
Just a small question, like it's not like different from the mouth, like you inhale the smoke to the lungs, and like a passive smoker.
This
like
is the mice are more passive smoker, yeah,
it's
because
not profound.
Yeah, so that's why we call it smoking exposure.
Okay.
But even you can see that even the smoking exposure can cause quite a lot of weight gain under cessation. Yeah.